In this video, let's take an overview of a very important topic, Monte Carlo analysis in project management, or you can say in risk management. Okay, so first we will take an overview of the introduction to Monte Carlo analysis. Actually, Monte Carlo analysis is a quantitative risk analysis technique used in project management to assess the uncertainty in project schedules and cost. Okay, so it implies probability distribution and random sampling to simulate the multiple project outcomes, helping managers understand risk, variability, and the potential project performance. Okay, so Monte Carlo analysis is particularly useful in construction projects where the uncertainties are high due to the factors such as fluctuating the material prices, weather conditions, labor shortage, and unforeseen site conditions. Okay, so uh, how Monte Carlo analysis works. So, Monte Carlo analysis operates by identifying the uncertain variable in a project, for example, duration of the task, cost of the materials. Okay, so number two, assessing the probability distributions to these variables. So number third, running the thousands of simulation using the random sampling from these distributions. Number four, analyzing the results to determine the probability of the various project outcomes, for example, completion time and total cost. So this process helps in making data-driven decision than the relying on the single point estimates. Okay, so number third, steps to conduct the Monte Carlo analysis. Define the product model. Okay, so break down the product into the activities and estimate the cost and duration, and so you can see use a work breakdown structure to list the activities. Second, identify uncertainty. Determine which activities or cost elements are the uncertain. Okay, so example, excavation work may take between 10 to 20 days depending on soil condition. Okay, so third, assign probability distribution. So assign a statistical distribution to each uncertain variable. Common distribution used. Okay, so common distribution used, you can say here the triangular distribution means the most likely, optimistic, and pessimistic. Actually, it's based on the 3 point estimation. Okay, so normal distribution, uncertainty around a mean. So uniform distribution, equal probability for all values. Step 4, run simulation. I use Monte Carlo software like Primavera Risk Analysis. Primavera Risk Analysis is, very good software for to analyze the risk, to run the simulations like a Monte Carlo simulations. Uh, so for the project risk analysis, or the crystal ball to run the thousands of the iterations. Okay, so actually, here you can see, read this word, the iteration. So, iteration, in risk management, iteration refers to the repeated process of assessing and analyzing risk to improve decision making. So, you can see each iteration refines the predictions by simulating the multiple possible outcomes based on uncertainties. Okay, so uh, I think it's enough. Okay, so next we have each iteration selects the random values for the uncertain variables and calculates product outcomes. Okay, so number step 15, step fifth, you can see analyze the results. So identify the probability of completing the project within a given time frame and budget. So generate a probability distribution curves to assess the risk exposure. So here you can see we have a number 4, Monte Carlo analysis for the construction schedule. risk. So, a construction project schedule is subject to risk like weather delays, labor shortage, and supply chain issues. So, example, here we have here high-rise building construction. So, the scenario is here, uh, contractor is constructing a 20-story residential building and estimates the schedule using the following duration for major activities. Here you can see we have the activities excavation, optimistic delays, most likely optimistic days, most likely days, then pessimistic days. Okay, so you can say it's a minimum, then most likely you can say the ideal duration. Okay, so pessimistic, so you can say it can take up to 20 days. That means the pessimistics. Okay, so here we have the 3 point estimation, optimistic, then most likely, then pessimistic stays. Okay, so as excavation, then foundation work, you can see 20, 30, and 40. Structural work 60, 80, and 100, then finishing 40, 50, and 70. So Monte Carlo simulation research. So after 10,000 iterations. So the analysis provides, you can see here, the P50 means the 50% probability project completion in 180 days. So next you can see second is the 80% probability project completion in 195 days. Third, you can see the 90% probability, you can see a project completion in 205 days. Okay. We can increase the iterations, okay, when we will run the Monte Carlo simulation. So we can increase the iterations to get more accurate results. Okay, so here we have the example. Here you can see Monte Carlo simulation project completion time distribution. You can see here we have the ones 50% probability that this project will take 180 days. Then you can see here in the middle you can see 180 days. Here we have the project duration, you can see in the days. Okay, so after that we have 80% probability that it will take 195 days, then 90% probability it will take 205 days. Okay, so here you can see it's red. Actually, interpretation, you can see if the contractor commits to 180 days, probability 50%, there is a 50% chances of meeting the deadlines. If the client wants a higher confidence level, for example 90%, so they should plan for 205 days. So I hope it is clear from the graph you can see and from this data. Okay, so this allows for the realistic schedule planning and proactive risk mitigation. Okay, so next we have a Monte Carlo analysis for construction cost risk. This was the duration risk. Okay, so next we have the for the cost risk. Okay, so, project cost can fluctuate due to changes in the labor rate, material prices, and unforeseen site conditions. Example, bridge construction project, you can say a scenario, a contractor is bidding for a bridge project with the cost estimate. So concrete, you can see here the 500,000 optimistic, most likely 600,000 pessimistic. You can see $150,000. Okay, so actually amount is in dollars. Steel 700,000, then most likely 800,000, and pessimistic you can see 950,000. So labor you can see 300,000, then most likely 350,000, and pessimistic you can see 450,000. So equipment 200,000, 250,000, most likely, then 300 pessimistic. So here is the bidding for the bridge project with cost estimates. So next, let's we have a Monte Carlo here simulation. You can see here. Okay, so actually, Monte Carlo. Let me zoom out, please. You can see here. There is the 50% probability that there will be 2 million. Okay, then 80% probability there will be 2.2 million dollars. Okay, so there is a 90% probability that it will take to complete 2.4 million dollars. Okay, so after the simulation analysis, we have results here. Okay, so Monte Carlo simulation results are here. You can see it. We have already uh, discussed here in this graph. So interpretation: if the contractor bid at 2 million dollars, so there you can say P50 means there is a 50% risk of cost overrun. You can see if the client wants higher confidence, so you can say probability should be 80 or 90%. The budget should be set at 2.2 million to 2.4 million. So this helps in setting the realistic contingencies and avoiding the financial losses. Okay, I hope the explanation is clear. Okay, so next, number six, you can see we have a benefits of Monte Carlo analysis in construction projects. So it improves the decision making, helps in choosing the realistic schedule and budgets, and it enhances the risk management, identifies the critical risk and suggests the mitigation strategies. Then optimize resources allocation, so helps in planning for labor, material, and machinery. Okay, so contract negotiation. So provide data backed justification for project timelines and cost. Okay, so number seven, limitations of Monte Carlo. So data intensive. You can see requires accurate probability distribution. Okay, so computational heavy. Okay, so you can see needs the specialized software and experience. It's very important. Okay, the right software and right experience or expertise. Okay, so assumptions dependent, so results are only as good as input assumptions. Okay, so this was overview of the Monte Carlo analysis in risk management or in project management. So I hope everything's clear. So thank you so much for watching this video. See you in the next video.